Good evening, guys. We learned a little bit about SOHCAHTOA today in class, so what we're going to do is I'm going to show you the first three problems on these guided notes, and these are applications of the SOHCAHTOA problem. So now, instead of just giving you the picture, you're going to have to draw the picture, and then you'll solve it. So these will be just like the ones that you were doing on the back of the worksheet that we worked in class today. So let's get going here. The first one, a tree casts a shadow that is 42 feet long. The angle of elevation to the top of the tree is 38 degrees. How tall is the tree? So let's get a picture here of what we're talking about. All right, so we've got a tree here. So let's just, draw us a tree here. All right, so here's just a little tree. All right, and we know that this tree casts a shadow that is 42 feet long. So we've got a 42-foot shadow there. So now, by using that and the tree, I've got a triangle here, and it forms a right triangle. Okay. Now, the question says also that the angle of elevation to the top of the tree is 38 degrees. Now, angle of elevation, you guys, is always at the bottom of the triangle. So here, we're looking at the base of the triangle. So this right here, that is my angle of elevation, which is 38 degrees. And then I'm wanting to solve for here, the height of the tree. So just like we did on the back of the worksheet, when you're looking at this problem, here we have 38 degrees as our angle. We want to know x, which is the opposite side, and we already know 42, which is the adjacent side. So we're thinking of which trig function deals with opposite and adjacent, and that would be our tangent function. So we would set this problem up by going tan of 38 degrees equals x over 42. And as we looked at in class today, we would multiply both sides by 42. So in your calculator, you would do 42 tan of 38, and you would get that x equals 32.8 feet. And that is the height of the tree. So pretty much the same thing you've been doing. We just had to draw the picture and kind of get a visual of it. So question number 2. A radio tower is 78 feet tall. Find the angle of elevation to the top of the tower at a point on level ground 60 feet from its base. So let's just go sentence by sentence. A radio tower is 78 feet tall. So let's just draw us a little, radio tower here. There we go. There's just a little radio tower, okay? And we know that this radio tower, okay, draw me a little line here, tells me it's 78 feet tall. So that's 78, okay? Now the question says find the angle of elevation. So this time we don't know the angle of elevation, so I'm going to label that as theta. And here again I put it at the bottom of my triangle. And it says find the angle of elevation to the top of the tower at a point on level ground 60 feet from its base. So here's the base at my right angle, and I've gone out 60 feet from that. So there's my 60 right there. So here again, when we look at this problem, we're dealing with opposite side, which is 78, and the adjacent side, which is 60. So we're going to set this up still using tangent. But now we don't know theta. So we have tangent of theta equals 78 over 60. Now this one's a little different from any of the ones that you solved yesterday because we need to solve this for theta. And the way we do that is we need to get rid of the tangent. And so here's how we get rid of tangent. We do what's called tan inverse. So we're going to do the tan inverse on both sides of this problem here. Now on the left, what happens is the tan inverse and the tangent cancel out, and we're just left with theta. And then in your calculator, if you will hit the second button, hit second tan, and then put 78 divided by 60, it will give you 52.43 degrees, which is my final answer here. Scratch that out, mess that up there. So 52.43. So now we found an angle for that one. Okay? All right, example 3. A line is attached to a kite. So let's go ahead and just put a kite up here. Got us a little kite, woo, flying high here. All right, and we got a line that's attached to it. It says when the kite has pulled the line taut, which means tight. It is 65 feet vertically from the ground. So here we've got this kite that's 65 feet vertical from the ground. It says the angle of elevation to the kite is approximately 60 degrees. So again, we draw us a diagram here. Angle of elevation is always at the bottom there. All right. Approximate the length of the line attached to the kite. So what this problem is asking you to find is this, the hypotenuse in this case. Okay. So here again, looking at my angle, 65 is the opposite side. That's opposite. And x is my hypotenuse. So this time I have the opposite side and I have the hypotenuse. So which trig function deals with opposite and hypotenuse? And that would be sine. So here we're going to go sine of 60 equals opposite over hypotenuse. Now we had some of these problems on the back of your worksheet today where you had x on the bottom. So we're going to multiply both sides by x and get x sine of 60, and here the x's cancel. You have 65. So remember we said if it was division, then that meant we were going to divide by the sine of 60 rather than multiply by the sine of 60. And when you do that, you end up with x equals 75.1 feet. And again, you can type that in your calculator. 65 divided by the sine of 60. And that's the application problems for SOHCAHTOA. So not too bad, just basic problems really. The trick is drawing the diagram, and you have to be able to read the sentence and draw the picture there. So we'll look at some more of these tomorrow in class. You'll get to practice, and if you have any questions, we can answer those.